regression. I'm telling you, this software is really giving me a hard time here. It's after 1 o'clock now, so whatever. All right, so you're going to need high school and beyond data, the high school and beyond data set. If you need to open that up, go ahead and hit pause and come back. Okay, so one of the things that linear regression allows us to do, it allows us really to extend our analysis towards policy implications. And so let's say that there's some argument about whether or not SAT math has any real value to predict some other outcome like math achievement. Okay, so let's say that I'm a college admissions officer and I want to look at what value does the SAT math have anyway? Does it have any relationship with math achievement scores? All right, so here's our math achievement. Okay, here's SAT math. Okay, both scale variables, great. And so the first thing I'm going to do, um, just for the sake of continuing what we've been doing in class and what your textbook does, I'm going to do a quick scatter with these two variables. Our independent variable, excuse me, is going to be SAT math. Our dependent variable, math achievement test. Simple scatter plot. Okie dokie. Now look at that. That's strong. Okay, that's extremely linear. And so, in the language that your text uses, it's like a good fit. Now look at that. I mean, that's really powerful. All right. So let's go ahead and do a linear regression. Our dependent variable, math achievement test. Independent variable, SAT math. Boom. Boom. Okay. So we know your eye should immediately go here. Is it significant? Yes, there's a significant relationship. How much variation in the dependent variable is explained by the independent variable? Over 61%. Okay, and then if I wanted to predict math achievement test scores using an SAT math score, I'm going here. Okay, so again, what's our formula? Y equals A plus B times X. What's Y? Y is our dependent variable, the value of the dependent variable that we're going to predict. What's A? Let's move it down here. A is our constant. So in this sense, our constant is negative 14.687. And then what's next? Slope. A plus bx. What's our b here? Our slope of our independent variable is 0.056. And so what's the value of our independent variable? We said 800. There's our equation. And so now y equals constant plus slope times independent variable. Y, our unknown dependent variable value, equals constant plus slope times our independent variable. We give it a value. This could be 700, it could be 450, it could be whatever, but for the sake of this example, we're going to make this 800. So now we're going to calculate it. Alright, so then we're going to go 0.056 times 800, and then we're going to add the negative value, 0.687. Okay. So someone with an 800 on the SAT, we would expect them to have a math achievement test score around 30. That's how you use the linear regression equation to predict. This is why it's a more powerful mechanism than correlation. Alright, now next we're going to do multiple regression, and hopefully I can do this before 4 o'clock in the morning.